we've been looking at the oxidation of alcohols. The oxidizing agent is the potassium dichromate, and we put that with the conch H2SO4. So I'm going to show you here about the reduction part of this. So the alcohol gets oxidized, the oxidizing agent gets reduced itself. So remember, this splits into its ions, so the two potassium ions and then the dichromate ion. And it's the dichromate ion that really is doing the work. So this gets reduced. So the alcohol gets oxidized, the dichromate gets reduced. So together we've got redox. Now remember, oxidation is loss, reduction is gain. So we're looking here now at the reduction half of the story. So we can do a half equation. Now half equations always contain electrons. So let's see how it works. If we start with the dichromate ion, so that is originally orange. So you do need to remember this observation, because it's going to change colour, and that's because when it gets reduced, that will change into the chromium 3+ ion, which happens to be green. So you've got originally orange, it goes green. That's how I remember it. Okay, so hopefully that'll help. So the alcohol's getting oxidized, this is getting reduced. How can we tell it's getting reduced? Well, we assign oxidation numbers. So this one's straightforward, it's the same as the charge of its ion. This one we need to work out. So remember, everything adds up to the charge. Now we know about oxygen, when it's in a compound it's -2. There are 7 of them, so -14, which means this has to be +12 for that to work. There's 2 chromiums, so each chromium then is worth +6. Now before we go any further, we need to make sure the chromiums are balanced. So I'm going to stick a big number 2 in front of that one. So per atom, if you will, we can see the oxidation numbers up here. So we're balanced for chromium. So the change in oxidation number then, if you remember how we did this in the redox topic in module 2, looking each atom of chromium, you're changing by 3, so you've got 2 of them, so you've got a decrease of 6 altogether. Now that change in oxidation number gives you the number of electrons being lost or gained. Now because it's going down, it's reduction, reduction is gain, so we're going to put our electrons on the left hand side. So there's our 6 electrons there. Now it's not over yet, because it's still not balanced, because we've got some oxygen here. So this is a complex ion. We need to balance for oxygen on the right hand side. Now we can't just put O2, because that would have an oxidation state of 0, and you can't have 2 changes in oxidation state in the same half equation. So we need something that has oxygen in that will still be -2. Okay, and what we use here is water. Now you might think, well, why do we use water? Well, don't worry about that for now. It's going to be something that you'll have in your toolkit, if you will, to help you to balance these more complex half equations. So we're going to put water on the right hand side, because we need 7 oxygens here, so we'll have 7 of them all together. I'll just squish that 7 in there. So we've balanced now for oxygens, but you might be thinking, hang on a minute, we've now got hydrogens on the right, and you're quite right, we have. So we need to have some hydrogens on the left now to balance those out. Now if you remember, we always say that this is with conch H2SO4, so this is now where our sulfuric acid will come in handy, because as an acid we're going to donate those protons, and that's what we can use to balance our hydrogens. So don't worry about the charge just yet. Let's think we've got 7 lots of 2, so 14. So 14 hydrogens, but it's the protons that we're going to use. All right, we're in acidic conditions. So if we count up all the symbols, we've got 2 chromiums, 7 oxygens and 14 hydrogens, and we've got our electrons in there because it's a half equation and it's the reduction half equation. Reduction is gain. Now it's not over just yet because we do need to check that not only is it balanced for species, but it's balanced for charge. So on the right hand side we've got 2 lots of 3 plus, so that's a 6 plus total. On the left hand side, well, we've got our 14 protons there, 14 pluses, and then we've got the 6 electrons, and we've got the 2 minus charge of the dichromate. So if we put all that together, 14 take away 6 take away 2, you end up with 6 plus as well. So these match, so it's balanced, so that's good. Okay, so they don't have to be 0, they just have to be the same, balance for charge. So if you understood all of that, fantastic. If you didn't, don't worry. It's something that we will revisit in module 5. In fact, that's when we will teach you about this properly. Okay, it's just been mentioned in this carbonyls booklet because we're just introducing this issue here. Now obviously we would then need to do the oxidation half equation for the alcohol to the aldehyde or the alcohol to the ketone, and then we could combine the 2 of them to give the overall redox equation, but we'll leave that till module 5. But for now you will need to remember that this is orange and it goes green, so originally orange goes green.